Hi everyone, in this video we will talk about depth first search, its working and algorithm. If this is the graph given to you, this is undirected graph. In depth first search we find adjacency list of every vertex. To find adjacency list of 1, we take 2, 3 and 4 connected to 1, so the adjacency list of 1 is 2, 3 and 4. Similarly, we can find the adjacency list for all vertices like this. Then, if we want to traverse a graph from vertex phi, then initially we create two arrays, that is visit and stack. As we know, the depth first search works on the principle of stack implementation. So initially visit and stack are empty. Then we take phi and we traverse the graph. We push phi into visit and in stack. Then we go to the adjacency list of phi. We take the first element from the adjacency list, that is 3, and we traverse 3. Then we push 3 into visit and in stack. Then we take the first element from the adjacency list of 3, that is 1, and we traverse the graph again. Then we push 1 into visit and in stack. Then we take the first element of the adjacency list of 1, that is 2, and we traverse the graph from vertex 2. We push 2 into visit and in stack. Then again we take the first element of the adjacency list of 2, but 1 is already in the visit, so we will not going to take that. Again, if you see the second element, which is 3, which is also in the visit, so we will not take that. Then we come to this third element, that is 4, so we will traverse the vertex 4 now. Now we push 4 into visit and in stack. Then we go to the first element which is already visited, then the second element which is already visited, third element which is already visited, so we go to the fourth element, that is 6, which is not in the visit. So we traverse 6 and we push 6 into visit and in stack. Now when we see the first element or the only element in the adjacency list of 6 is 4, which is already in the visit. So we do the back tracing, where we pop the last element or the top element from from the stack, that is 6, and we traverse 6 again. So again we will not find any new element in the adjacency list which is not in the visit. So we pop 6 from the stack, then we take the top element from the stack, that is 4 now. So again we traverse 4. Now in 4 we have find that the last element, that is 7. We will go from 1, 2, 5 and 6, which are all in the visit, but 7 is not in the visit. So we will pop the last element, that is 4, from the stack, but as we know that the last element is not in the visit, so we will again push 4 into stack and we will traverse 7 now. So now we are traversing 7. So when we traverse 7, we push 7 into visit and in stack. As 4 gets a new element, because of that we have pushed 4 into stack, and now we will pop the element from the stack one by one. We pop the top element first, that is 7, and we traverse the graph. Nothing is fine, means the new vertex is not fine in the 7th adjacency list. So we will again pop 4. In 4 also we have not find any new vertex, so we pop 4, then 2, then 1, then 3, and then 5, and now the stack is empty. If we get any new element in this traversing, then we will push that vertex into stack, and we again going to pop that vertex from the stack and traverse. So for this example, this is how we traverse: 5, 3, 1, 2, 4, 6, 4 and 7. So now we see the coding of this algorithm. For coding we are going to use JavaScript. So let's start. First you create adjacency list, which is a object. Then you create a array visit. Then you create a stack. Then we create a function called depth, which will take two arguments, src and destination. Then in this function So in this function we are going to create a adjacency list. So if src, that is the source vertex in adjacency, equal to false, means initially the adjacency list is empty, so it will be a false statement. So we will initialize src with a empty array. So adjacency of src equal to empty array. So we initialize src with empty array. Similarly we will do the same thing for the destination vertex also. So destination in adjacency is equal to false, then we initialize the adjacency of destination equal to empty array. Then if src in adjacency and destination in adjacency of source equal to false, then in adjacency of src we will copy all the elements of adjacency of src and we append the destination after that. It means if src in adjacency, now we have initialized it, so yes, definitely src in adjacency is true, but destination in src, if it is false, then we copy all the elements of src adjacency and we append with destination. So if you don't know about this, then if array equal to 1, 2, 3, and if I have to copy this into a new array called suppose temp, in temp if I want to copy the element of array, then I will just copy in this way, array comma, and I can append any element after that. So this will be the temp array. So the similar thing we are doing here. So for source we have done this, similar thing we will do for destination. So if destination in adjacency and source in adjacency of destination equal to false, then we update the destination adjacency by copying all the elements of adjacency of destination and we append it with src. So to save time, I have already created a graph, that the example that we have seen. So if you want to see the adjacency for this graph, then we will just run this. So nothing is showing because we are not console this. So console.log adjacency. Now if we do run this, you can see how the adjacency is created for all the vertex. Now the main thing is to traverse this graph. So for traversing we take another function called traverse, which will take one vertex and in this we will take that vertex and traverse. So if visit does not include the vertex, then we will push that vertex into visit dot push vertex. Now we traverse all the adjacency vertex, that means all the vertex in the adjacency list of that vertex. So let num of adjacency vertex so it will take all the vertex from the adjacency and we will traverse that. So if that num is not in visit or in stack, so if it is not include in the visit dot include, so if that num is not included in the visit and if it is not included in the stack also, stack dot include, then and then only we will traverse the graph. So now in this we will push the num into stack. So stack dot push num, and then we will traverse the num. So we are pushing the num into stack and we traversing it. So in this line of code we are getting a new vertex every time we are traversing, but when the vertex comes, when we don't get any new vertex, then we will start popping the element from the stack. So we will do that in this. So if stack dot length is not equal to 0, then we will traverse the graph with the top vertex in the stack. So traverse stack dot pop and we take the top vertex from the stack. So this is how we code. So now we put the traversing vertex, that is suppose vertex from vertex 5 we have to traverse, then we take traverse 5. Now we will run this. So actually we are not consoling the visit, so we console that. So console dot log visit. So now we can see how we are traversing. So now we can see how we are traversing from 5 to 3, 1, 2, 4, 6 and 7. So this is how we code this algorithm. Thank you for watching, and if you like this video, subscribe to my channel to support this channel.